Hello and welcome to our group's presentation. We are from Group 7. We are here excited to present to all of you about our project, which is Program Loop. Okay, our task involve a C++ program designed to determine the smallest and largest numbers from a user's input. This simple yet effective program serves as a foundation for understanding more complex algorithm. It operates by comparing each new input with the current extremes and updating them as needed. Let us examine how this logic is constructed in C++ and how we approach the translation into MIPS assembly. Okay, so as you can see on the screen, this is the C++ code for the program loop. So for the initialization, the program begins by initializing two integers variables, smallest and largest, to the largest and smallest possible integer values respectively. This is a setup to compare and find the actual smallest and largest numbers from the input. Okay, so next, the program then displays a welcome message, which is this message, welcome to larger and smallest number program, and then it asks user to enter an integer input, and that entering zero value will stop the program. Okay, next, the core of the program is the while loop that continually executes until it's broken by a condition, which is when we enter zero value, so it will break the loop. Inside this loop, the program reads the integer from the user, this one in number. Okay, so and then if the input number is the first one that will be checked by the is first number flag, it is set both as the smallest and largest number. And then this because at this point is the only number we have. Okay, so for every subsequent number entered, the program compares it with the current smallest and largest values. If the new number if the new number is larger or smaller than these values, the program updates the smallest or largest accordingly and outputs a message. So if the number is largest, it will display number and the largest integer so far. If the number is smallest, it will see out or display the number and the smallest integer so far. So if it is neither smallest or largest integer, it will just print the number. And then if the users enter zero, the loop will be exited. And after exiting the loop, the program prints the smallest and largest numbers found and then ends with a thank you message. This one, smallest integer, largest integer, and program ends. Thank you. So we run the program to see how it works. Nampak tak?
Sekarang ada.
Okay, so aku continue. Okay,
Ha.
so when we run the program, it will display like this. Welcome to largest and smallest numbers program. This program will keep track which value is the smallest and which is the largest. Enter a integer, enter zero value to stop. So I will follow like in the guidelines. So for the first number is number 10. Okay, so number 10 is the first number, so it will display the number and the message, which is 10 is the first value and therefore the smallest and largest integer so far. And then I will put number 6. So number 6 will be the smallest integer so far. And then I will put number 11. So 11 will be the largest integer so far that replace the number 10. And then I will put number 4. So number 4 will be the smallest integer so far. So I will put number 5, number 6. So if the number is neither smaller nor largest, it will just display the number. It will just print the number. Okay, so I will enter number 3. So number 3 will be the smallest integer so far. And then I will enter number 15. And number 15 is the largest integer so far, and I will enter 0 to exit the loop. So I okay, so it will display the smallest and largest integer. which is the smallest is 3, the largest integer is 15, and it ends with a thank you message. So I think that's all from me. I will pass to the next presenter. Thank you.
So this is our MIPS assembly code, and in the first section we use the data section, which in the data section we define strings that will be used for displaying messages. This includes welcome message, prompt for user input, message for the first, the smallest and largest integer, a new line character, and a message for displaying the result and ending the program. For the text section, there is initialization. We start by printing a welcome message using the syscall instruction. Register T0, T1, and T2 and T3 are initialized to keep track of the smallest, large, and control flags. For the input loop, we check if the prompt has not been displayed. We enter loop name in input loop to continuously read integers from the user. We check if the prompt has been displayed using control flag T3 and display it if necessary. The user's input is read using syscall 5, and the entered integer are stored in S0. For the fifth one, to handle the first integer, we check if the entered integer is the first one. If it is, we print the integer and set it as both the smallest and largest so far. We use the move instruction to transfer the integer to register T0 and T1 and set a flag to T2 to indicate that the first integer has been processed. And then after that, we go for the comparing and updating smallest and largest number. For subsequent integers, we compare them with the current smallest and largest value. If the entered integer is smaller than the current smallest, we update the smallest value. If it's larger than the current largest, we update the largest value. For the printing message, we print the appropriate message based on the compromised made message include indication if the entered integer is the smallest or the largest so far. The loop continues until the user enters 0. So it will be just keep going and editing if the smallest compared to the other smallest one, and then just move it. And then goes also with the largest number. For the printing result and exiting, we print the smallest and largest integers and closing a message. The program then exits gracefully using the syscall instruction with li v0 and 10. In conclusion, this MIPS assembly code efficiently tracks the smallest and largest integer entered by the user, demonstrating the use of register, control flags, and branch instructions in a low-level programming environment. This will be my present for the MIPS code, and now we're going to go to the next presenter.
So after this, we put our code in our Mars simulator and we run it. So at the output here, the program will ask the user to put in the integer. So for now, I will start with the value 10. So since 10 is the first value, therefore is also the smallest and the largest integer in the same time. So that I'll enter in the second value, which is 23. So because of 23 is larger than 10, so 23 will become the largest integer so far. So taking 5. So the 5 will become the smallest integer. So when I enter a value which between the 5 and the 23, which is 12, we only display the 12 only, since it is not the largest and the smallest. So to exit this program, I would just type in the 0. And the program will conclude the smallest integer so far and the largest integer. So that's all. So I'll pass it to the next presenter. Thank you.
So in conclusion, the MIPS program represents a valuable endeavor that has provided insights to the of the assembly language programming and the architecture of MIPS processor. Through the development in this program, several key concepts have been explored, including instruction set architecture, memory management, and data manipulation at the low level. And in summary, the MIPS program has served as hands-on learning experience, allowing for a deeper understanding of computer architecture and assembly language. The process of designing, coding, and debugging has honed programming skill and provided practical insights into the inner working of a processor. Thank you.